this recommendation. Thank you. Uh, okay, in previous session, uh, I talk about the goals of distributed system. One goal of distributed system is uh, scalability. Okay, some techniques are introduced for scalability. One of them is distribution. Uh, okay, three techniques, three methods are present for distribution in these slides. In this file. Uh, okay, I know in the previous session I talked about this topic. I talk about using move computation to client. It's one technique. After that, I talk about this decentralized naming services, which is a data server, which the data server consists of uh, many data about the IP address and host name, and data server is responsible to translate uh, the host name that you write in the browser to the IP address, to the associated IP address. Uh, okay, data server includes many data around the world. Each website has host name and associated IP address. Okay, all data about this concept are stored in the DNS server. Okay, so the DNS server must consist of some matchings around the world, and the data must be distributed uh, between some matchings. Okay, uh, this is one technique for distribution. This is very similar to the distributed database, very similar to it. Okay. Another technique for scaling is replication. Replication is a process of making a replica or copy of something. This is the definition of replication. Again, replication is a process of making a replica of something. In this figure, you can see uh, the description of not description. Okay, one example of a replication. Uh, in this figure, you can see the data R is inserted to this node. Okay, so insert data R in this node. Okay, after that, because of the number of user or other reason, this data uh, is stored uh, on some other matches. Okay, in these three on these three matches. Okay, so The A is forwarded to these three matches. It's called a replication because uh, there is one original data or original location, and and this original location is stored on some other matches, and okay, the user can connect to the original location or uh, some other the other location which has the replica of the original data. It's called replication is very important and is used in distributed database. Uh, uh, replication can uh, create some challenge for the system, doctor. Uh, are there about two techniques for distribution? One of the scaling. Uh, the replication is another technique for scaling. Yes, for scaling. Uh, the definition of scaling. In the scaling, when uh, there is a significant increase in the number of users and the resource. Okay, by using this technique, we can increase the number of resource. Uh, we can increase the number of resource. Okay, so by increasing the number of users, okay, by using this technique, we can uh, uh, increase the performance of the system. And in another way, in another sentence, I can say uh, uh, the uh, effectiveness of the system is remain. Uh, Alaikum assalam. Okay, so I can say this is the application is another technique for scaling, not distribution. Distribution is another technique for scaling. Okay, in the next section, in the next week, I want to talk about the replication. Inshallah, okay, I want to talk about the details of replication. So it's enough for now. And after, uh, okay, in the next week, okay, I'm going to define the replication and some challenge of replication in distributed database. Usually, I can say the challenge of caching a replication. The most challenge, the important challenge of replication is consistency. Since there are multiple copies of a source, changing one copy will make it different from the rest. Uh, okay, so this challenge is very important. Okay, the different techniques are introduced for this challenge. Okay. Uh, Another challenge of caching and replication is synchronization problem. Each machine use its own clock Okay, so there is no unit clock between the matches. Okay, so another challenge is synchronization problem because we also compare uh, these the clock of this matching to find uh, the final change of the data. Okay, so okay, I say you that I'm going to talk about this challenge in more details. Security is another. Uh, Please, is it possible to add physical distribution of resource? Yes, Mustafa, it's good sentences. Yes. Mustafa say that uh, uh, okay, the computing power per node is limited. Okay, so by using the replication, we can add new uh, and physical matches. Okay, so by using these techniques, okay, different user can connect to and use the data synchronously. Uh, okay, another technique for scaling is high communication latency. High communication latency. Uh, uh, Nazar asked, how does security represent a challenge? When the data is distributed over some matches, okay, for security, you must you should to provide a security for some matches, not what matching, and also, there are links between the matches. Okay, so also you should to provide the security for the links between matches. Okay, so this is more harder in comparison when you have one matching and you need to provide security for one matching. Okay, if providing security for the network is not easy and is a challenge for any network. Okay, is it clear, Nazar? Among the security problem are DOS denial of services attack, which are sending a large number of requests to the server so that it is not working and become unable to receive their new request. Uh, yes, but this problem uh, is exists on the network and for each node. Okay, so this usual uh, attack for any network. Okay, not all. Okay, there is not difference between one server or some server. Okay. Uh, you're welcome. Uh, High communication latency is another technique for scaling. Avoid waiting for a response to something else. Uh, and yes, this is one technique to increase the performance of the system. Avoid waiting for any request and for response. Okay. Usually in the network, when a server uh, send a request for any machine in the network, okay, the server can continue its working and okay, can do other tasks and okay, until the response come back to the server or any machines. Okay, so in this time, the server or each machine can do something else. Okay, so using asynchronous communication is a technique that can be used for to hide communication latency. Uh, okay, in this regard, uh, separate handler must be used for incoming response. Okay, when a request is sent from one system to another, the system does not wait for its response and pays to other requests. In this regard, the system uses different handler for each connection. Okay, this is another technique for scaling. High communication latency. Okay. Uh, okay. This slide shows the observation of scaling and problems. You know, applying a scaling technique is easy, except for one thing. Replication. Replication. Uh, in replication, we have multiple copy of one thing of one things. Okay, having multiple copies, cache or replicator leads to inconsistency. Modifying one copy. What is a consistency? Modifying one copy make that copy different from the rest. Modifying one copy makes that copy different from the rest. Okay, so always keeping copy consistent and in a general way require global synchronization on each modification. Uh, and global synchronization preclude large scale solution. Okay, okay. Uh, Finally, I can say if we can tolerate inconsistency, we may reduce the need for global synchronization, but tolerating inconsistencies is application dependent. Tolerating inconsistencies is application dependent. Okay, in, in the next slide, I'm going to talk about the different types of distributed system. Okay, before this title, uh, I talk about the goals of distributed systems and some technique for scaling for distributed systems. Okay, now the title is different and okay, I'm going to talk I'm going to introduce some types of distributed systems. Any change to one copy of the data must occur to the rest of existing copies. Yes, Nazar. Yes. For for the rest of existing copies, but it need some special method because each machine uh, use its own uh, clock, and sometimes uh, one data which is stored on some machines can be used for some application for some users, and these user application must use the same data. Okay, so we need to have consistency between some machines, between all machines, and this is challenge. Okay, so I say you that in the next week I'm going to talk about this challenge, inshallah. The types of distributed systems can be categorized into three types: distributed computing system, distributed information system, and distributed pervasive system. Okay, and uh, distributed computing systems uh, usually used for high performance computing. Okay, some uh, famous systems such as cluster computing system, cloud computing systems, and grid computing system are belong to distributed computing systems. Uh, there are very important and famous systems, and uh, um, this system uh, are changed over time from 2000 year. These systems are changed, and many researchers and company around the world uh, have been focused of this onto these systems, and uh, increase the performance of these systems. Okay, so uh, I introduce them shortly in the next slides. Another distributed information system, another distributed system is this distributed information systems. Uh, these systems mainly are used for management, for integration of business function. Another distributed information system is transaction process system, is a system which is belonging to the database and is used for store the data and change the data. Okay, and for query processing, I'm going to talk about the transaction process system in this term. And enterprise application integration is the final. Uh, Sorry, I my internet connection is disconnected temporarily. Okay, uh, I'm sorry. And distributed pervasive system is mobile and embedded system. You know, this system is very uh, common between the people around the world using mobile and embedded systems, home system, and sensor network. Uh, these systems are belong to the pervasive systems. Uh, okay. Uh, Firstly, I'm going to introduce, or not introduce, shortly introduce the distributed computer system. Okay, I say you this system, these systems are used to for high performance computing. One type of this system is cluster computing. Uh, Many distributed systems are configured for high performance computing, and one of them is cluster computing. Cluster computer essentially a group of high-end system connected through a LAN, sometimes high-speed LAN. Usually, not overally. Usually, these systems, these high-end systems, are homogeneous. They are identical. They use near identical hardware and sometimes same OS. One note. One note. Uh, Manage other nodes. Okay, so there is a single managing node usually in this in the cluster computing. Uh, It's called master node. It's called master node. So in another sentence, I can say a computer cluster is a set of loosely or tightly connected computer that work together so that in many respects they can be viewed as a single system. This is one one aspect of distributed systems. The distributed system uh, is appears for the user as a single system. Okay, so uh, you can see this aspect in cluster computing in the cluster computing too. Does the system have one master node, or is it possible to add more than one master node? Usually, one master node is used for manage some nodes. And sometimes, Nazar, okay, and sometimes there are some master nodes, but the matches are divided between them. Okay, so for example, one master node manage five matching, other master node manage five others matches. Okay, these matching should be different. And again, there is one other master node that manage uh, master node. Uh, this is like uh, the tree configuration. The tree configuration. Each master node manage the work of a specific set of nodes. Yes, Nazar, it's correct. Uh, okay, I say you that the master node manage the application, manage the task between the compute node. Okay, these nodes are called compute node. Okay, so a special libraries are used in master node to divide the task between the compute node and usually the parallel program uh, the parallel program uh, are used to execute uh, on this system on the cluster computing. Okay, in this figure you can see the module on master node can be different from the modules on compute node. Uh, and also you can see the standard network or high speed network can be used in this type of systems. Unlike grid computers and grid computing, the grid computing is another type of uh, distributed computing systems. Three uh, well-known distributed computer systems are cluster, grid, and cloud computing. Okay, unlike grid computers, each node, each node in the computer cluster set to perform the same task. Usually, these nodes perform the same task. Yes, control and schedule by software which is installed on the master node. Dual nodes in the system perform one task, usually the same task. Yes, or do not perform its own task, usually the same task and one task is performed on the cluster computing. Yes. Okay. Another type of distributed computing system is grid computing. Uh, the grid computing is the next step of high performance computing system and distributed computing system. Okay, after cluster computing, the grid computing is introduced. Uh, okay, the grid computing consists of lots of nodes from everywhere. Usually, these nodes are heterogeneous, not homogeneous. In the cluster computing, I say you that the cluster computing some homogeneous nodes, but grid computing consists of heterogeneous nodes. Grid computing disperse across several organizations. Okay, different organizations collaborate with each other to provide appropriate resources for grid computing and can easily span a wide area network. Can easily span a wide area network. These are some uh, important characteristics of grid computing. To allow for collaboration, grid generally use virtual organization. In a sense, there is a grouping of users. There is a grouping of users, or better, their ID, that will allow for authorization or resource allocation. Grid computing is the use of. Can you repeat the previous point, course? There was no sound. Uh, Nazar, which slide? This slide or the next? Okay. Uh, some characteristics of grid computing is introduced in this slide. The grid computing includes lots of nodes from everywhere which have the following characteristics. There are heterogeneous, not homogeneous. These nodes disperse across several organizations, but these organizations can be okay, can be a virtual organization, and the node can easily span a wide area network. Okay, to allow for collaboration for different users and companies uh, to provide uh, the grid computing, okay, the grid generally use virtual organization. Okay, every user can be connected to this system as a uh, organization, and the resource can be used in these systems for the resource for it can be resource for all users. Okay, I'm going to talk about this type of systems in the next slide in the on the figure. But usually I can say in essence there is a grouping of users that will allow for authorization and resource allocation. A group of users construct the grid computing. These their resources are shared between all users that collaborate with each other to construct the grid computing. Uh, okay, so in this figure you can see one figure, different user around the uh, 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 everywhere. Okay, from everywhere can connect to each other through the network, wide area network, or other types of network, and the resources can be used by any users. Uh, okay, so there is a need to have a special module which is called Grid Resource Management System. This module have the information of all resources around the system, and when a user wants to use a special resource, the user must be send requests to Grid Resource Management System, and this module is decide about the request. Uh, this module, Grid Resource Management System, after receiving the request, search to find appropriate resource for the users according to some metrics, such as the distance between the resource and the users, the bandwidth, the queue request for each resource, or the cost of using the resource, and other metrics can be used uh, uh, in this module to decide about each request from the users. Grid computing is the use of widely distributed computing resources to reach a common goal. Okay, a common goal is defined for a grid computing. For example, this common goal can be the high performance. For high performance, uh, not for one user, for all users. Okay, so the mean performance uh, should to increase for the system. Okay, so a common goal is introduced for grid computing. Grid computing is distinguished from conventional high-performance computing systems such as cluster computing. Okay, Grid computing is distinguished uh, from cluster computing in that each node in grid computing is set to perform a different task or application, not the same task. You know, I say you that in cluster computing, the same task is performed on each node, on each compute node, the same task, but in grid computing, the different task or application is defined for and each node in the grid computing is to perform a different task or application. After grid computing, the cloud computing is introduced. The cloud computing is introduced from more than 10 previous years. I think is introduced around 2010 year, and this computing, this cloud, the cloud computing is uh, used in some devices, in many devices nowadays. Uh, the cloud computing, the users, the people around the world know the cloud computing and use the cloud computing for storing data, for to perform the application. Okay. A cloud is an elastic execution environment of resource providing and meta services at multiple granularities. In this figure, you can see the cloud computing consists of some servers, application servers, database, and different devices such as mobile, PC, okay, and then now kitchen sink and other devices can be connected to the cloud computing. Can you give an example of the application of this type of system in real life? Cloud? I think the cloud, you can see the cloud in your phone. Uh, uh, you can use cloud for to store data. Can other student? Uh, Grid computing is used by a special company or organization, and the grid computing need special resources, and some a special organization must provide appropriate resource for this type of system. And okay, so the usual people, the usual users cannot use this type of system. And so in some universities, such as for example in Ferdowsi University, or many other universities around the world, the grid computing is used by the students in this and some special company uh, use grid computing, but grid computing is uh, not used by the usual user around the world, because uh, the, this for using this system you must uh, uh, have a provide okay, they need a special software. You must to uh, uh, authenticate to use the grid resources, and your system and your resources must be managed by a special system, GIS, Grid Information System. Okay, so the grid computing system uh, is provided and is used by a special university and companies, not usual users around the world. You can compare the grid computing and cloud computer in this slide. Uh, Welcome, Nazar. Okay. Uh, uh, Sorry, I have a meeting at 11 o'clock today. Okay, so no, I should to uh, finish the class now, and inshallah, and uh, I continue the speaking. Speaking about the cloud computing and comparison between the cloud computing and grid computing and other slides at 12 o'clock, inshallah. And now I should to finish the class, okay, and go to the meeting. Uh, Sorry. Okay, so bye for now. Inshallah, uh, the next session uh, at 12 o'clock. Thank you.